Ultrafast EV chargers are revolutionizing the way electric vehicles are charged, addressing one of the biggest concerns for potential buyers: long charging times. The introduction of these high-speed chargers, capable of charging an EV to 80% in a matter of minutes, is transforming the electric vehicle landscape. In this detailed exploration, we'll look into how ultrafast EV chargers work and their technical specifications. We will also dive into the evolution of charging infrastructure and the comparison between ultrafast chargers and other charging options. Before diving into ultrafast charging, it's important to understand the fundamentals of how EVs charge. All electric vehicle batteries require direct current to charge, but the electrical grid supplies alternating current. This means that AC power from the grid needs to be converted into DC to charge the car's battery. In most cases, this conversion is handled by an onboard charger, which is built into the vehicle. There are three basic levels of EV charging: Level 1, Level 2, and Level 3. Level 1 uses a standard household outlet and is very slow, adding about 5 miles of range per hour of charging. Level 2 chargers are faster, utilizing higher voltages and providing 20 to 60 miles of range per hour. Level 3, also known as DC fast charging, bypasses the car's onboard charger and sends DC electricity directly to the battery, offering significantly faster charging times. Ultrafast charging is a subset of Level 3 charging and represents the cutting edge of DC fast charging technology. These chargers can deliver up to 350 kilowatts of power, allowing for rapid energy transfer and dramatically reduced charging times. Understanding the technology behind these systems helps to paint a clearer picture of how ultrafast chargers work and why they are crucial for the future of EVs. Early electric vehicles relied solely on slower charging methods, which used to be Level 1 chargers, which plug into a standard household outlet, were the only option available for many EV owners. These chargers are convenient because they can be used anywhere there is an outlet, but they are painfully slow, where charging a modern EV with a Level 1 charger could take over 2 days to fully recharge. As electric vehicle technology advanced, so did charging technology. Level 2 chargers became more popular because they offered much faster charging times. These chargers, which operate at 240 volts, can provide around 20 to 60 miles of range per hour of charging, making them a more practical solution for daily use. Many EV owners install Level 2 chargers at home because they allow for overnight charging that can fully replenish the battery by morning. However, as the range of electric vehicles grew and more drivers began using EVs for longer road trips, the need for even faster charging became apparent. This led to the development of DC fast charging, or Level 3 charging, which bypasses the car's onboard charger and sends electricity directly to the battery at much higher rates. While Level 2 chargers might take several hours to recharge an EV, a DC fast charger can do the same job in less than an hour. Ultrafast chargers take DC fast charging to the next level. While early DC fast chargers were capable of delivering around 50 kilowatts of power, ultrafast chargers can deliver 150 kilowatts, 250 kilowatts, or even 350 kilowatts of power. This allows for incredibly fast charging times, with some EVs able to gain 80% of their battery capacity in under 30 minutes. Ultrafast chargers are designed to deliver massive amounts of power to an electric vehicle's battery in a very short period. To understand how this works, it's essential to know a few key components of the charging process, from how the charger converts AC to DC, how it manages high voltage and current, to the cooling systems involved and the communication between charger and vehicle. So just like with slower chargers, ultra-fast chargers need to convert the AC from the grid into DC for the car's battery. However, unlike slower chargers, this conversion doesn't happen inside the car. Instead, it happens within the ultra-fast charging station itself. The charger converts the AC from the grid into DC and then sends that power directly to the car's battery, bypassing the onboard charger. Ultrafast chargers operate at extremely high voltages and currents, which allows them to deliver large amounts of energy in a short time. For example, many ultrafast chargers operate at 400 or even 800 volts, which is significantly higher than the 240 volts used by Level 2 chargers. This high voltage allows for faster charging speeds, but it also means that ultrafast chargers need to be built with robust components to handle the increased electrical load. One of the challenges of ultrafast charging is managing heat. Charging a battery quickly generates a lot of heat, And if that heat isn't managed properly, it can reduce the efficiency of the charging process or even damage the battery. To prevent this, ultra-fast chargers are often equipped with advanced cooling systems that keep both the charger and the vehicle's battery at an optimal temperature during charging. Ultra-fast chargers and electric vehicles need to communicate with each other to ensure that charging happens safely and efficiently. This communication happens via the charging cable, with the car and the charger exchanging information about the battery's state of charge, temperature, and other factors. The charger adjusts its output based on this information to ensure that the battery is charged as quickly as possible without causing damage. One of the biggest challenges in the development of ultra-fast chargers has been the lack of standardized charging connectors. Different automakers have used different types of charging connectors, which has made it difficult to create a universal charging infrastructure. However, in recent years, the Combined Charging System (CCS) connector has emerged as the standard for DC fast charging and ultra-fast charging in many parts of the world. The CCS connector allows for both AC and DC charging, making it a versatile option for electric vehicles. Most new electric vehicles come equipped with a CCS connector, which allows them to use both Level 2 chargers and ultra-fast chargers. Another common connector is CHAdeMO, which is used by some older electric vehicles, including the Nissan Leaf. However, CHAdeMO is less common in newer vehicles, and its use is declining in favour of CCS. Tesla, on the other hand, uses its own proprietary connector for its supercharger network. However, the company has started to open up its supercharger network to non-Tesla vehicles in some regions, which may require the use of an adapter. As ultra-fast chargers become more common, we are seeing the development of ultra-fast charging networks designed to support long-distance travel. Tesla's supercharger network has been the most prominent example of this, with the company installing thousands of fast and ultra-fast chargers across the globe. Tesla's V3 superchargers, for example, are capable of delivering up to 250 kilowatts of power, allowing for rapid charging times. Other companies are following suit. Charging networks like Ionity, Electrify America and Fastened are installing ultra-fast chargers at strategic locations along highways and in urban centres. Ionity, for example, has built a network of 350 kilowatt chargers across Europe, allowing EV drivers to travel long distances without worrying about running out of power. While ultra-fast charging offers many benefits, there are also some challenges and limitations. One of the biggest challenges is cost. Ultra-fast chargers are expensive to install, with some costing over $50,000. This makes them impractical for most EV owners to install at home, so they are primarily found at public charging stations. Additionally, using ultra-fast chargers can be more expensive than slower charging methods, which means that drivers may need to pay a premium for the convenience of fast charging. Another limitation is the availability of ultra-fast chargers. While networks are expanding, there are still many areas, particularly in rural regions, where ultra-fast chargers are not yet available. This can make long-distance travel challenging in some areas, as drivers need to plan their routes carefully to ensure they have access to charging stations. Finally, not all electric vehicles are capable of using ultra-fast chargers. While most new EVs are equipped with the necessary technology, older models may not be able to take full advantage of ultra-fast charging speeds.